Hello everyone. It's time to begin our Savnet working group meetings. Welcome all you to attend these meetings. First, I will introduce the overall situation of our working group. As normally, we first introduce the notable. So this is the reminder for the Ietf policy, mainly for the IP patent and the code of conduct. So here I just mention some important point. So the detailed policy and should be referred to the BCP 79. And as a reminder, we want to emphasize the following point. First is the by participating in IETF, you agree to follow the IETF process and policies. And second is if you are aware that any contribution is related to the patent of yours or your companies, you should disclose them, or else you should not participate in the discussions. And the third is as a participant or attend of any ITO meetings, you acknowledge that you are the written audio, video, and photograph record may be published. And the fourth is your personal information that you provide to the ITF will be handled according to the ITF policy statement. And the last point is for during discussions, you should agree to the code of conduct of ITF and work respectively in other participants. So this is some guideline for the ITF code of conduct. Here is our working group status, and currently we already have 6 working document, and the intra-domain problem document we have planned to submit to the IEST, but it returned to us, and we will begin the second target working group last call after the meetings. And there are some updates for other working group document. Except this working group document, there are some active ID internet draft, and they include some mainly focus on the intra-domain and inter-domain solutions and some general component. So the goal of this meeting, I think, is not really different from the previous meeting. So first, we want to confirm the update for the intra-domain 7 PS document, and after it, I think we should every participant should focus on considering the following issues. The first is where to deploy the service rule within the intra-domain, because such consideration will influence our future selection of the intra-domain solutions. And currently there are several proposals for the intra-domain service proposal, and we would like to encourage our contributor to converge to one general intra-domain solutions. And for inter-domain, in this meeting, we also updated the inter-domain PS document, and there are also updates for the previous proposed inter-domain service solutions. And we encourage every participant to read also other persons' contribution and the solutions, and you can compare them, provide your analysis for the pro and cons of their proposal. And there are one important after this discussion, we will discuss deeply for the service scaling problems raised by Jeffries. I think we can discuss intensely in the mail list, and we wish to have some fruitful discussion in these face-to-face meetings. And the last part is the general management. component. For example, how to get the series rule and some benchmark method and some Yan data model. So this is the agenda we have published in the mail list. There are mainly 3 parts. First is the intra-domain, and the second is the inter-domain, and the last one is some OM and management proposals. So if the time permits, we will the last presentation will make some introduction for their short and the PCPA extension for the say policies. So this is our general consideration for these meetings. Joe?
It's just 2 quick comments. One, reminder to the people in the room, make sure you're in the Meet Echo tool because you need to raise your hand when you go to the microphone so that we queue between remote and local properly. 2, I want to note that a number of people sent slides very late. That can get awkward. We almost didn't get some of the slides into the presentation set. For the future, please get your slides in sooner. Now let's go start those slides. Thank you.
Yeah, so, okay, here we list the first presentation for the update of the intra-domain problem segment.
Hello everyone, I'm Lan Cheng from Zhongguancun Lab. I'm going to introduce the update of this intra-domain problem statement document. And before I introduce the updates, I'd like to first briefly introduce the background. And this informational document currently includes a gap analysis of the current operational intra-domain cell mechanisms and informational requirements for technical improvements. And here is the document history. In 2022, we first submitted the first version of this individual draft, and in 2023, we submitted the first version of this working group document. And in last year, we requested the working group last call, and in the beginning of this year, we requested the Ietf last call, and in April, this document was returned to the Savnet working group. And because of 2 main concerns. The first concern is that standard track protocol changes must be based on standard track requirements, but the current requirements are informational, and some terms are not clearly defined. And our responsible AD gave us some suggestions. The first one is to share the latest version with the impact working groups such as AOSR to get broader input. And then it's recommended to split this document into 2 parts. The first part should be an informational document that outlines the use cases and gaps. And we can remain the current informational requirements, but we need to make it clear that these requirements cannot be used to initiate protocol changes. And another part is a standard track document that clearly defines the normative requirements for protocol solutions in the future. And then we share the latest version with the AOSR list on the mailing list. And before I introduce the updates, I'd like to make the following clarification. First, no IGP extensions are currently foreseen, and so this document doesn't describe any solution space, solution design, or protocol requirements. And any protocol changes would require a standards track requirements document, not a non-normative reference to this informational document. And here list the discusses we received during the IETF last call from Gunter and the head. They are related to the related works and the terminology and protocol requirements. So we revise this document accordingly. And here lists our main updates compared to the last version. In section 1, we revise the terminology. Specifically, we remove the definition of host network and rename the customer network as subnetwork and modify its definition. In section 2, we describe why EF-PURPF is not considered in this document. And in section 3, we revise the section titles for both subsections and revise the corresponding description. In section 5, for the requirements, we add a language to make it clear that these requirements cannot be used to initiate protocol changes. And as in terms of the terminology, in last version, there are 4 terms. There are host network, custom network, host-facing router, and customer-facing router. And in this word, we delete the term of host network because we, after discussing with Gunter, we agree that this term is not accurate. The definition of host network is that a set of hosts, but it's not a network because it only consists of hosts. So in the current version, we directly use host instead. And for the term of custom network, somebody suggested that the customer can be ambiguity and can be confusing because customer can be maybe a custom AS, but we do not intend to say that the customer network is AS is a part of the AS. So we rename it as subnetwork, and the subnetwork is a part of the AS, which is connected to one or more routers of the AS for outbound connectivity. And it only originates traffic, but doesn't transit traffic for other networks. And we also delete the 2 terms host-facing router and customer-facing router because we do not want to assume the intra-domain could be only deployed on those routers. Where to deploy SAL should be discussed in the architecture document instead of in this problem statement document. We also add a language to describe why EF-PURPF is not considered. It's because EF-PURPF is specifically designed for inter-domain SAL. It is used on AS's external interface facing a custom AS or facing a lateral peer AS. So it's out of the scope of intra-domain SAL. And we changed the titles of both subsections in section 3, and because to avoid the assumption that intra-domain SAL is only deployed at the edge. And then this section purely describes the technical gap, which is independent of where SAL deployed. And the routers suitable for deploying intra-domain SAL should be discussed in the architecture document. And in the section 5, for the requirements, we first remove the specific requirements for customer-facing routers, host-facing routers, and AS border routers because they are all related to solution design and which should be discussed and described in the architecture or future solution documents. We specifically add a language to make it clear that this information cannot be used for standards track changes, and any protocol changes would require a standards track requirements document. Okay, thanks. Any questions?
So, Jim Guichard. So, a couple of things. One thing that wasn't clear to me is you mentioned that when I returned the document that I made some suggestions, but you didn't say what the outcome of those suggestions were. And what I'm concerned about is that I haven't seen any discussion about that on the mailing list in terms of, should we split the document into two separate documents? What are the pros and cons of that? What's the working group consensus on that particular point? So I'd like to understand what's happening there. The second thing I want to make clear is that when I returned the document, I did not say that the requirements must be in a standards track document. So I want to make that clear. What I said was, if the requirements are not going to force any kind of protocol changes, then that's fine. It can be within an informational type document because you're going to use that to build an architecture, and that's fine. What I'm concerned with is if at some point you decide, we need to make some protocol changes, then at that point, then we need to have a discussion about a requirements document that can be normative for those protocol changes. So that I just want to make that clear. But my main concern at this point is what you're actually going to do with this document, because if it comes back to me as a single document, I'm going to want to understand whether that is based upon a working group consensus, not just based on what the authors decided to do with the document. Does that make sense?
Yes, I think it's clear. And I directly copy the suggestion from the mail.
I understand, but what you didn't say is what the working group has decided to do, and whether that conversation has actually happened in the working group. I haven't seen it. Maybe I missed it on the mailing list, but I've seen emails going around, but they weren't copied to the working group.
Okay. Yeah, and for the last major concern, I think first, this document doesn't assume IGP extensions are necessary.
No, I understand that.
Yes, and
we don't need to waste time here. All I'm saying is that I'd like to at least see a conversation about this on the mailing list, and that if whatever decision is taken by the working group in terms of how to process this document, whether it stays a single document or separate documents, that needs to be a working group consensus.
Yes.
And the only way you're going to make that consensus is if you've had that conversation on the mailing list, and I haven't seen that. So that's all I'm saying.
Oh, okay. I understand. And I'm open to comments from everybody in the working group.
Sriram, NIST, can you go back to the slide where you talk about intra-domain SAF for traffic from rest of the internet? 9, it's number 9. So the intra-domain SAF for traffic from the rest of the internet, how does that differ from inter-domain SAV on a provider interface?
Yes. We make the boundary between intra-domain and the inter-domain based on their capability. And for intra-domain SAV, if it's used for traffic from the rest of the internet, for example, the provider interface, it can only check the spoofed data packets using an internal source IP address of the AS.
Okay, so you are saying that it is different from inter-domain SAF for the provider interface. It's different from that.
Yes,
the last bullet.
It's based on the capability.
Okay, yeah, I'll talk to you offline to get a better understanding.
Yeah, okay, sure.
Thank you.
Okay. Hello, everyone. This is Minxin from Zhongguancun Lab. I'm going to give a very quick introduction about the updates on general SAF capabilities, which is about what kind of capabilities we should have in terms of the counterplane perspective. Okay. Last meeting, we have a first version of working group draft, and now this is about the second version. The main updates about this version is including that first of all we add a new traffic monitoring policy, and then it's about what kind of default traffic policy we should have, and then something about the relationship with the traditional SAF mechanisms like that. Okay, here's some details. First of all, is if you guys remember that last version, we have a kind of traffic monitoring policy only about some sample. So now we add a new traffic monitoring policy is about count, which means we can give the number how many package validated as invalid. This will give initial sense of what can happen in the data plan, about the source spoofing. So with relatively lower cost, right, compared to sampling. The second update is about the default policy combination. Actually, this kind of thing raised by Jeff on the last meeting session. Here's the some ideas about the policy combination. First of all, we have two kind of policy, right? One is traffic control policy, and the other one is traffic monitoring policy. So the initial default combination we suggest is that the traffic control policy is discarded, and then traffic monitoring policy will be counted. So in this case, we can get very initial sense about the SAF capability, but with lower cost. And meantime, we'd like to suggest that the default combination could be changed per system level, per interface level, or per different SAF mode, right? This is about the policy combination. The other update is about the relationship with traditional subtool, which specifically is the URPF, right? If we look in terms of the control and the management, URPF still is a tool for us to generate these sub rules. But in terms of the data plan, actually this kind of thing is related to our safe mode 1, the interface-based perfect allow list. So basically, we suggest that in terms from the data plan point of view, we suggest that replace the traditional tool expression by the new sub rules. Right? This is our general suggestion, but there is one special case that some may say, okay, we have loose URPF to generate very wide, very long allow list for your specific interface, and then we want to block some of them, right? This is kind of popular scenarios may exist, and then what can we do? Anyway, this is two way. One way still, we can use unified self rule expression, right? We can detect the block list from the, URPF-based longer allow list. And in this case, we can, get only one validation process, right, in the data plan, but with, higher capability, like support all kind of traffic policies. The cost, of course, sometimes maybe the SAF rule expression, too much rules and then too much policies may cause more pressure in terms of memory in counterplan, data plan, right? So the another suggestion is that we can do it, like composite. So first of all, we can do traditional nose URPF validation. And then we go to the Sav mode 2 to do interface-based prefix bar list. Okay, this kind of thing, we may save some kind of word expression memory, but of course, with cost that we lost some kind of capabilities, like traffic control policy and traffic monitoring policy. This is both okay. Yeah, it's up to Windows implementation. Okay, that's all for my part. Any comments?
Yeah, I think these two modes also will related to the discussion is scaling problems.
Okay.
Okay.
Sure.
Okay.
Okay.
Okay, hello everyone. I'm Wei Wang from China Telecom, and I will give a brief introduction about the draft intra-domain source address validation solution based on BM SPF. The intra-domain SAF aims to prevent outbound packets from spoofing source addresses of other subnets or AS, and inbound packets from external AS from spoofing local AS source addresses. And this draft have two goals, and one is to find general solutions applicable to edge routers, internal routers, and AS border routers. And the second one is to simplify the sub-rule generation based on FIB table. And as we can see in this figure, the router D and E, we call them AS border routers, and they could learn all intra-domain prefixes from the IGP protocol, and the interface shop on the AS border routers should enable mode 2 subrules. And when AS border routers generate its subrules, its sub entries, they should perform the following procedures. First, they should traverse all the prefixes in their FIB tables, and then it should add all prefixes and the corresponding interfaces into the block list on their interface shap. And for the edge routers, they can be found in this figure as router A, B, and C, and they can connect to the customer network or the host network. And for their interface shop, they should enable the mode 1 SAF rule. And when they generate SAF entries, they should first traverse all the prefixes in their FIB tables, and then add all the prefixes and their corresponding interfaces into the allow list on this interface. And for the multi-home custom network, to achieve the effect of engineering return traffic based on the granular addresses space, we should configure two kinds of routes on the multi-homed edge routers, and we call them the summarized route and detailed route. For example, if the packet is transmitted to the customer network through router B, and they come back from router A, and when they come back to the router A, the source address of the packet is the IP address of router B. So it cannot hit the detailed route of router A, but it can hit the summarized IP address of the router A. So it could pass the Ceph filter. And the third scenario is for the internal routers, because in some span leaf scenarios, instead of deploying the Ceph mechanism on the leaf routers, the operators think we can select it to deploy on the span routers, and this can simplify the overall deployment of the sub-rules within the network. And the internal route, such as the span router in this figure, this span router can enable mode 1 sub-rule on its interfaces, and the processing of the allow list generation is performed in accordance with the add routers. And with these three scenarios, the Ceph procedures in router, in edge routers and internal routers are the same, and the Ceph procedures in AS border routers can cover all the relevant prefixes. And this page, I would like to give a very brief introduction about BM-SPF mechanisms. We have proposed one individual draft in LSR to describe this mechanism. Its full name is a bidirectional metric-based shortest path first mechanism. And with this, by using this mechanism, we can avoid the asymmetric routing. Two neighbors use the same bidirection link matrix for SPF algorithm path calculation. And when routers communicate with this mechanism, packets can transmit it through the same path, and the same interface is used for sending and receiving packets between two routers. And in conclusion, the BM-SPF-based Ceph solution can simplify the intra-domain Ceph, and it covers all types of routers. And that's all. Any comments?
Peter Pshenak, Cisco. So I looked at that BM-SPF draft. I don't understand it because what it proposes is if you happen to have an asynchronous metric, it picks the highest value of the metrics and use that in the SPF. Well, but what if I want to have asymmetric metric? Because there are cases where people intentionally use asymmetric metrics and that's what they want. You can't assume that you can fix it just because you want to do a subnet. So that's one comment. The other comment is, and it's a generic one, which I've expressed several times, I strongly believe the subnet should be done at the border of the AS. It should not be done inside because there are all sorts of issues which you will hit if you try to do so.
Oh, okay, thank you. This draft we have uploaded in LSR, but maybe we haven't presented it on working group meetings. So maybe
If you do, I'll make the same comment there.
Yeah, Peter, I try to explain. You know, where to deploy the service rule, we have not determined where to deploy the service rule, and we have some discussion in the Savnet, but have not finally determined. Currently, we have discussed other operators. There are necessary and the scenarios that the inter-router should deploy the service rule, not only the edge or border routers. Okay, this is the first reason. The second reason is why we consider the BMSP. BMSP must the proposal of BMSP SPF just want to ensure the traffic, the bidirectional traffic follow the same path within the IGP domains. I think it is easy to accomplish within one intra-domains. So this.
Sure, but the way you solve the problem is you avoid the problem, but the problem exists. You can't just fix it.
I know the traffic asymmetric exists, but we can solve it, and if we based on the symmetric path, and then it is very simply to accomplish the service within.
Okay, we can take this on the list. I think it would be more
Okay.
productive. Thank you.
Jeff Haas, HPE. To your point, I agree. That this problem should not exist. No, we should only be solving this at the border routers. Hitting the specific requirements here about asymmetric routing. Asymmetric routing is desirable in some cases, and as an example, firewalls that are deployed at where you have your border routers commonly need to share state in order to balance things. What this demonstrates is this is a common problem for these types of networks. You can't define it out of existence by telling them change how IGPs are used.
Yeah, I think such proposal just provided one new motivation or new solutions. So where to adopt it, we can determine later. We want to solve it. We can do the service rule within the internal routers in some simplified ways.
I think you'll find if you're trying to address the problem by requiring that things behave a certain way, you are dooming SAF enforcement for intranet for failure, because people will not want to deploy it because it has these properties.
Okay, I just want to add one quick comment. I just agree with Frank and Jeff. There were a lot of debates in the working group before about whether to deploy intra-domain SAF in border routers or in internal routers. I think most of us believe that, okay, we should deploy it in border routers. We spend a lot of time discussing these things in the mailing list. So I hope that, okay, the working group can just make consensus based on, okay, what most people believe. Okay, yeah, that's all.
Okay, I think we can discuss intentionally on the list more clearly. Okay.
And hello everyone. Hello Chair, can you hear me?
Yeah, okay, we can hear you.
Okay, let's start. This is Li Xuting from China Telecom, and my topic today is Intra-domain on-demand source address validation mechanism. Below is a link to our draft. We kindly request you review for the draft and welcome your comments and feedback. On this slide, I'd like to briefly walk you through the motivation behind our proposal and the key area of on-demand service
survey activation. Let's begin with looking at current survey methods. Common approaches such as ACL, URPF, and IGP-based survey mechanism are widely applied today, but there share a few limitations. And the first, SAL requires manual rule configuration and maintenance, which is difficult to scale, especially in large or dynamic environment. And in the same, URPF, through automated to some extent, is typically deployed only at network edge, and its street mode often risks driving legitimate traffic if not carefully configured. Um, uh, Meanwhile, methods like BMSPF rely on HP topologies and only enable a minimal set of interfaces, assuming shortest path of forwarding model. Now, here's the problem, and this method overlook modern routing behaviors, and they don't account for a surveillance policy with the best routing or faster route mechanism. View traffic paths change dynamically based on real-time considerations or operator intent. So this led to two crucial challenges. One is wolfing exposure, and the other is false positives. So to address this, we propose an on-demand survey mechanism. It's simple but powerful. Instead of pre-installing survey rules on all possible interfaces, we activate the survey only when and where it is needed, based on policy changes. This ensures better coverage and more efficient resource use. Why it makes sense to integrate survey with on-demand activation? First and foremost, this approach provides on-demand granular control over traffic passes. Um, because in modern network, traffic doesn't always follow surface paths, or operators deploy segment routing policies, and when faster route mechanism like TIFR to optimize performance and resilience. A static survey configuration simply can't keep up with dynamic behavior. And second, it have us a strict balance between security and flexible. In survey methods, we have mechanism like BMSPF, which prefers validation based on the minimal set of interfaces. That's secure but often too rigid. It may block legitimate traffic in policy-driven scenarios. We propose this solution, and this model enable us to move beyond static enforcement and toward an policy-aware validation system, which is exactly what today's network needs. And now let's look at how on-demand survey works in practice. And the activation workflow consists of three key stages. The first, the process begins when routine or policy event or precise effect forwarding passes. And for example, this could be a change in SRV policy or the activation of a faster route path due to link fear. And updated service specific, specific message are then propagate along the new path from the source router. This messaging for each validation routers about the required validation rules, typically prefix-based filters. And after receiving service-specific information, only validation routers in that path selectively activate service rules
雪天，
on evolve.
雪天，would you like to? 雪天
Okay, I can hear.
you have no time to finish your presentation.
Yes. Now, let's briefly introduce the use case of our solution. So, when there are multiple types of traffic within this including less sensitive voice traffic and few transport traffic with high batch requirements. And the default path is router 1, router 2, and router 3. And when policy to meet these requirements, the controller install an SRV policy that steers traffic along an alternate path, router 1, router 4, and router 3. As soon as this SRV policy becomes active, the data plane path chain and this will the and rather the source router updated survey specific information, propagates the updated information to other routers along the new policy path and dynamically triggers survey rule activation. For example, on and router 1 survey is enabled on S1 and connecting to router 4, and router 4 survey is activated on S2, leading to router 3, and in the same and router 3 survey remains active on the destination-facing interfaces such as S3. So this dynamic activation ensures that both the packet cannot exploit alternate paths created by traffic engineer policies while avoiding the overhead of validating unused links. And
雪天，
limited to the time.
雪天 So
Okay.
we must cut your presentation. So okay. Okay. Would you like to finish the conclusion quickly? Okay.
Okay. In briefly, and we our solution has BMS-PF in dynamic network where traffic and forwarding paths change due to policy changes such as SRV policy or network topology change FR, and few validation gaps on alternate paths. So that's our goals of solution. That's all. And more information you can read our draft. So thank you.
Okay, Peter.
Peter Pshenak, Cisco. So it's not clear to me how you want to dynamically instantiate a rule in cases like FRR. In FRR, the remote router decides to reroute the traffic in the hardware real time. How would you propagate the subrule to be propagated even before that rerouted traffic hits the box. It's not clear to me. I just don't see how you can do that.
Let's explain. It's the same as we want to utilize some space information. You know, if we deploy the FR technology, the router will calculate the backup path. So after its calculation, it can use the space information to propagate the newly passed to open the interface on the routers. This is the general ideas.
I'll move it to the list. I don't really understand what you are saying, but I just don't see how you can do that, because even if you pre-program this, at some point you have to activate it. And how would you activate it before the traffic hits the box? I don't think it's a solvable problem, unless you want to signal it inside the traffic.
Okay, thank you.
Okay, thank you. And we will answer your question on the mailing list. Thank you.
Okay, I'm Libin Liu from Zhongguancun Lab. I will present the updates of the draft source address validation in inter-domain networks, gap analysis, problem statement, and requirements. The latest version for this document is version 09. This is a revision summary of version 09 compared to version 08. First, we did minor refinements to the no export and DSS scenario examples in section 4.1. Second, we updated the requirements descriptions for improving validation accuracy over existing mechanisms in section 6.1.1. Third, we did minor refinements to the introduction test for EFP UIPF in section 3. Finally, we clarified some wordings on incremental or partial deployment requirements. Sorry, I cannot control the slides. Okay. For all of them, we updated the Savnet workgroup chairs on the revision consensus. In section 4.1, in the DSR scenario for illustrating hidden prefixes, we removed the no export configures from the figure for the DSR examples. Since the no export configure is not needed for illustrating the DSR scenarios, but may lead to misunderstandings. In fact, the hidden prefixes in DSR scenarios are because the edge servers connecting to S1 send the return traffic with source addresses in P3 to the user, which AS1 does not advertise the prefix P3 using BGP, only AS3 advertises it. In section 6.1.1, we revised the requirement for improving validation accuracy over existing inter-domain mechanisms, making this document focus on the requirement while avoiding constraining the future solutions. The updated requirement is that for IIS, as shown, like ASX shown in the slide, performing inter-domain sub on an interface connected to a neighboring AS, it must permit all prefixes whose legitimate traffic can reach that interface. But while blocking all others that cannot, this general principle applies to customer, little peer, and wider interfaces. as shown in this slide for ASX, customer later peer, and provider interfaces. In the same section, we also clarified the scenarios where both spoofed and legitimate traffic arrive from the same direction or interface. In such cases, wider deployment can help. For example, as shown in the left figure, only S4 deploys SAV and the other S does not. A spoofer connected to S2 sends the spoofed traffic with source addresses in P1 to S4. In this case, S4 cannot differentiate between the spoofed traffic and the legitimate traffic. Thus, it permits the spoofed traffic. As shown in the right figure, if AS3 also deploys the SAV, it can block the spoofed traffic at the interface facing AS2 and permits the legitimate traffic. All the comments about this document had been addressed, so we request the work group last call. Thank you.
Any questions? So if there are no questions, we will move forward for okay.
Good afternoon. My name is Sriram from NIST. My co-authors are Igor and Doug Montgomery. So we made some changes in version 7 relative to version 6. They mainly have to do with some motivation that was provided by Jeff Haas's draft about inter-domain scaling. So there is the synchronization issue to make sure that all the different data elements that are required for this SAV table computation, they come into place ahead of the SAV table computation takes place. I'll talk about the details of that. And then there are also the dynamics of BGP and RPKI that need to be considered in the SAV table computation. Since I'm going to jump to my backup slides just to say a few words about the basics of bar SAV, and then I'll come back. So this picture kind of explains bar SAV, the various components of it that all come together to collect all the ASS. Initially, it collects all the ASS in the customer cone of the interface that we are interested in to compute the SAV table. So the circle there is the customer cone that we are interested in. So we want to be able to get all the ASS and then get all the prefixes. The way the bar SAV does it by using complementary methods. One of them is use BGP and collect the AS paths, use the AS paths and the ASPA information to recursively walk down from the top AS connected to the interface AS3 and then walk down recursively provider to customer, and so on until you have collected all the ASS based on BGP AS path. Similarly, we complementarily use ASPA data also, which provides customer to provider information relationships. So with that, we try to gather all the ASS in the customer cone. Once that is done, we look at the prefixes that were announced in the BG updates, as well as the ROAs, which contain the prefixes originated by this set of ASS that we just discovered. And that gives us the list of prefixes that should be expected on that interface for possible like source address use. So that's the basic methodology. It tries not to miss anything, including the no export situations, including the DSR situation. So that's a basic introduction to bar SAV. all the details and the algorithms are in the draft fairly well written at this point. So the question of coordination of BARSAV with FIBRIB and RPKI, primarily we are saying that we need the FIBRIB information, ribbon information to compute the SAV table. So let it converge, let the ribbon and the FIB converge. And then at that point, start the computation of the SAV table in BARSAV. And so we need to allow some delay or lag time for the convergence to happen after the start of a BGP session or after the restart. At that point, we start computing, and BGP up to BGP is dynamic, obviously, so updates will keep coming in, and those updates will be factored in as quickly as possible to add to the prefixes if they indicate that it should be added. Similarly, any withdrawals that affect the SAV table for that interface will also be there will be a lag for that. There will be a hysteresis because withdrawal could have happened because of a transient event, link failure, recovery, or something. So we would allow a lag of, say, maybe 48 hours. By doing that, we avoid flapping in the SAV table, that you remove a prefix and then you add back. Since it's a continuous process, the computation is a continuous process, and it keeps up with the dynamics of BGP update arrivals as well as withdrawals. And then there is the RPKI, ROAS and ASPA's element to the source of truth data that we are using. So that is also dynamic, and we factor in that dynamism as well. So by doing this, we are sequencing everything, allowing enough delay to make sure that the SAV table is computed correctly and completely. Also, during the discussions about Jeff's draft on scaling, some questions came about where should we do it. And this is a table pretty old from RFC 8704, where we had done some measurements. So depending on whether you have a very large global ISP or relatively small, say, regional ISP, the range of the prefixes, total number of prefixes in the table can go from 32,000 to 1,000 ballpark. And if you have many smaller ASs with just a few customers, it can be even smaller, a few hundred. So if we can focus on those ASs towards the edge to deploy SAV first, we would be able to we would not face the issue of memory size, the FIB memory size. That's the point here. So that's my presentation. Thank you. Well, questions welcome.
Thank you.
Hi, Sarah. As I always say that this is very good, enhancement for EFP. Okay, and can you go to slide 8?
Slide 8?
Yes. I'm wondering if any case that, because right now we have to get the complete knowledge of the custom size, right? So is there any case ASPA or local RIB, both of them cannot find any customer AS? I feel like maybe some case, which is low list here.
Oh, you're saying, are there any cases that I'm aware of where the AS in the customer cone might not be found?
Yeah, maybe ASPA not registered it and also is hidden from BGP local RIB.
Right. No, yeah, unless you construct an example, I won't be able to comment on that. If you are able to construct an example where that happens, we can discuss it.
Okay. Another thing is about, about the hidden prefix, we required a new rule, right? Kind of a thing. I mean, given that we also have a kind of draft TOA. I mean, that new rule or TOA may relate to side drops or something like that. We may I'm not sure what we can do that we may think of with side-offs.
Right. So
Okay.
your question is, are we considering using TOA for possibly discovering more prefixes that may be hidden?
Yeah.
Is that
Yeah,
the question?
either TOR or LOR.
TOR.
It's kind of case, more related to side-offs working group. Yeah.
Sure.
Okay.
As this picture shows, the ROA is already helpful for discovering the DSR prefixes. In addition to that, if what Jeff has brought up are the hidden prefixes that are only used for source address but never routed. For those prefixes, I'm following the discussion. If TOA seemed to be the right object, we are happy to accommodate that in this solution as well.
Okay.
Thank you very much.
Hello everyone, Lan Cheng from Zhongguancun Lab. I'm going to introduce the considerations for self-specific information and the need of traffic origin authorizations, TOA. And the first question is, what information does inter-domain self need? Let's presume an AS receives a data packet with a given source IP address from a given external interface. And self at the interface requires two kinds of information. They are traffic origin information and the traffic transit information. The traffic origin information is used to identify which ASs will source traffic using that given source IP address. And the traffic transit information would be used to identify whether the interface is expected to receive traffic originated from that AS. And advanced inter-domain self solutions typically use BGP updates and ROA to obtain the traffic origin information. And they can use BGP updates and ASPAR to obtain the traffic transit information. And today, I'm going to talk about the problems of using BGP updates and ROAs to obtain traffic origin information. The problem is that BGP updates and ROAs do not provide the complete traffic origin information for hidden prefix. A hidden prefix is a prefix that an AS uses only as a source address for sending traffic, without announcing a corresponding route to it in BGP. And there are several examples. I think we have discussed this on the mailing list. And in such cases, the corresponding IP address holder may intentionally choose not to register ROA for that AS, which will never announce a route to the hidden prefix. So in this case, if SAV use BGP updates or ROAs to obtain such traffic origin, it will fail to discover all traffic origins for this hidden prefix, and then it will drop the legitimate traffic. So, in summary, SAF needs traffic origin information, and because it requires a mapping between a prefix and the ASs that are permitted to source traffic using that prefix as a source IP address. But when the traffic origin is not a root origin, there will be a problem, and no existing information source can provide the traffic origin information when it differs from root origin. So we believe a new mechanism is needed to enable IP holders to explicitly authorize ASs to source traffic from a prefix, even without announcing it in BGP. And recently, there has been a lot of discussions on this topic about how to implement the TOA functionality. and there are two possible approaches. The first approach is to define a new IPK-assigned object for TOA because it has clear semantic boundaries between TOA and ROA, and it can avoid unintended side effects on the existing ROA. Another approach is to extend the semantic of an existing ROA field, such as the max length, as suggested by Eagle. And in this way, can be potentially easier to implement and deploy, but it may risk of affecting the existing ROA. And we also ask for some ASN1 experts for suggestions, and based on the discussion, we finally think the first approach would be preferred. And these are some considerations of TOA usage, but these are preliminary ideas and need further improvement. First, using TOA requires avoiding redundancy. We think there is no need to register TOAs for information already covered by ROAs. This would help reduce RPKI object count and the system overhead. And so when is a TOA needed? I believe the first case is to authorize a traffic origin that is not a route origin. And a TOA may also be needed when we want to explicitly signal that the ROA listed route origins are the only traffic origins. And then SAV can use both ROAs and TOAs to identify the complete set of traffic origins for a prefix. And so, any comments?
Sriram Nist. I have a couple of questions. First question is is there an estimate on how many prefixes there may be in the internet that do this, that it's only used for source address but never routed? Do we have? Minuscule. Okay. So that's good to know. So then there is a possibility that you could perhaps define a special purpose ROA. In addition to Igor's suggestion with max length, one could also maybe assign a special purpose AS number. And for these minuscule set of prefixes, we create a ROA with IANA assigned a special AS number, and conservatively, we would include all of those small number of prefixes in any SAV table anywhere on any interface. So we are just increasing the size of the interface by a small number, but we are able to accommodate that using a slight variation of the ROA. Again, the same question may arise about not changing the semantics of the ROA, but here I'm saying that you just need a IANA assigned special ASN, and you might be able to accomplish that and conservatively include these few minuscule number of prefixes in every possible SAV table everywhere on any interface. A thought, we can discuss it.
Yes, but if you are seeing the possible way to achieve the TOA functionality, I think we need to ask for the experts.
Yeah, if folks inside the ops insist that we don't want to further play with the semantics of ROA, we can stick with something like TOA in that case.
Yes.
Yeah, thanks.
Continue. Second.
Yeah, and then I'm going to introduce the update on BICONSAV. Let's have a quick review of BICONSAV. It has two goals. The first goal is to avoid improper block, And it means if the allow list-based filtering may have improper block problems because it is allow list is not it is not complete. A conservative way is to use loosely IPF to avoid improper block. So Reconcile has the second goal to reduce improper permit than solely using the loosely IPF. And the key idea of Reconcile is to generate a block list which contains prefixes exclusively belonging to the provider code. And the rationale is that these prefixes should not be used as source IP address in data packets received from any customer AS or lateral peer AS unless there is a root leak. So the main update is the introduction of the usage of tools in Reconcile. And when we generate the block list, in the second step, Reconcile identifies prefixes exclusively belonging to the protocol by using tools. And because tools are helpful to discover the traffic origin of hidden prefix. And we provide the benefits and trade-offs of using allow list or block list. And because allow list based filtering requires the completeness of the allow list. So if the allow list is incomplete, it will improperly block legitimate traffic. But if the allow list is complete, it can ensure zero improper block and zero improper permit. In this case, allow list is the best choice. And block list-based filtering doesn't require the completeness. One of its key advantages is that it doesn't risk blocking legitimate traffic. And however, its effectiveness depends on how comprehensive the block list is. Because the spoofed traffic not covered by the block list may still pass through and will cause improper permit. So we finally gave the recommendations for ISP and maybe network operators. If the network operator can determine that the allow list is complete, it's highly recommended to use an allow list on that interface. But if the network operator cannot, so they can use a more conservative way to use loose IPF and the block list together. This can help avoid improper block while blocking more spoofing data packets than solely using loose UIPF or solely using a block list. And we also suggest that network operators are allowed to manually modify or configure the block list according to their local knowledge. Okay, that's all. Thanks.
So I have made this comment before. You have a very large number, like millions or even more, unallocated IPv6 addresses. And how do you make sure that those are blocked in case they are spoofed?
The loose IPF can block those spoofed data packets, I think. Do you mean how to block the data packets using an unallocated source address?
So if you are proposing that the allow list solution, which has a set of prefixes that are allowed, and any other prefix is not allowed.
Yes.
You have millions and maybe even more, tens of millions or more unallocated IPv6 prefixes. If they are spoofed, they are not in your allow list, then they would not be blocked. That you would have improper admit.
Yes. So, sorry, I still don't understand what do you mean. So, do you mean the size of the block allow list contains millions of IPv4.
Yeah, okay. So you're saying that let us use loose URPF and the block list together.
Yes.
How do you implement that? Either you subtract the block list from the loose URPF and then you make that the, I'm sorry. Yeah, you subtract the block list from the loose URPF and make that the allow list. Is that what you're proposing?
I don't think so. I think we can first check the data package by using loose URPF. And if the data package uses an unallocated or non-routed source IP address, it will be blocked. And then we recheck that data package by using the block list.
Yeah.
So it's still a block list, not an allow list.
Yeah, no, I was using allow list maybe incorrectly. What I meant was that your block list doesn't contain the millions of IPv6 unallocated. So you're not able to block them. But if you subtract that block list from the loose URPF, then you have not a block list, but you have an allow list, like normally we do with SAV on interfaces towards the customer. So normally we are used to like having a allow list rather than a block list. If you compute a block list and only go by the block list, it doesn't work, right? So that is why you are saying that first use the loose URPF and then use the block list. So instead of like a two-step process, like compare with one list first and then another list second, you can simply subtract the block list from the loose URPF, in which case it is no longer a block list solution. It is back to being the normal traditional allow list solution, right? But you still have a very large.
Yes, I understand. I see. But here I call it block list because it is the format, the data structure of this list is a block list.
Yeah. Okay.
Yes.
But one other comment is that you still have a very large. It's just loose URPF, which is like of the order of 1 million prefixes, and you're subtracting a small number from that. So you still have a pretty large SAV table, and you still have pretty you are permitting. You have a lot of improper permits, essentially, right? You agree?
Yes, we will not contain all of those prefixes in the block list.
Yeah. So
yes,
I think I think you are saying that you would have improper permit, and you are trying to make a yeah, I guess. So my 2 points are that ultimately it becomes an allow list. It's not a block list solution. Ultimately it becomes an allow list because you must subtract the block list from the loose URPF, and then compared to other solutions like BarSav, etc., which focus on that interface and only try to find the prefixes that come in from the customer side on that interface and creating an allow list doing that, they are able to both block the unallocated prefixes and bogons, etc., and also they are able to keep the SAV table manageably small. And most of the places where you would deploy this initially, if you do that, just focus on the allow list based on a direct computation of what you should expect based on something like BarSav. Then you have a very manageable small SAV table, and you have you don't have the problem of dealing with like the unallocated IPv6, etc., that is already factored in.
Yeah.
Yeah.
Yeah. Thanks. And I will think more about it and get back to you.
Hi, Anton Schuren, Liberty Global. Can you go one step further where you were? No, further. So the one that you had. No.
Which page?
the last one. You just switched it before. Anyway, so we just had the inter-domain problem statement where it says, you know, the difficulty with ACLs is that they're difficult to maintain because they are maintained manually. Well, in our case, we don't maintain them manually, by the way, but we have a proprietary provisioning system for our filter lists. So it's not only manually, but now I see that you recommend operators to manually update. Network operators are allowed to manually update or modify. So that doesn't, for me, that doesn't compete with the problem statement that you don't want to do any manual updates anymore.
Yes, so the block list can be generated automatically, but the network operators are still allowed to modify it.
And that was the thing that we wanted to prevent, right?
Mm-hmm.
We don't want to do any manual updates anymore because it's not only a lot of work, but it's not scalable. So I agree with you, you know, you should do the allow list, but if you choose something where operators still need to manually modify lists, that's not very viable.
Yes, so it will avoid entirely relying on the manual updates. Yeah, it's mostly rely on the automatic way to generate that block list. This is just an optional way.
I don't have an evil bit in routes that are, or in prefixes that I should reject, right? How do I recognize that I should block?
Yeah, so this just assume if you wanted to modify this according to your local knowledge, you can do it.
The way I read this is, when I see spoof traffic coming from an interface, I must add that prefix to the block list of that interface. And so every time I see spoof traffic on that interface, I need to add something to the...
I must stop your discussion because there are arrangement, okay?
Yeah.
Let us discuss on the list, okay?
Okay, thanks. We can.
Hi everyone. Today I hope to present the main updates of our draft on inter-domain source address validation based on S relationships. During and after last Savnet meeting, we received some comments about our draft from chairs and other researchers. The first comment is about that there are many unclear meanings and confusing uses of our specific terms, such as SAB rules, validation rules. So we learned from other drafts and standard files and add definitions about our terminologies in section 2 and add a section about requirement languages to modify unclear descriptions and standardize our term uses in our draft. The second is that we received the comment that our draft scheme is a little far from the actual networks, and so it lacks some details about implementation. So we adjusted our system design and add some implementations of our two key components of our system in section 4. And in summary, that our main updates is that we added terminology and requirements language and to standardize our term uses of our draft. And we add some implementations of the key components in our inter-domain SAV system based on current security mechanisms in section 4. The second is that we validate the feasibility of our current implementations using the simulations, and we introduce this work in Hexagon. About the terminology, we hope to standardize the term use, and we refer to the working group drafts and use the SAV rule, take the SAV rule as the rule that indicates the validity of a specific source AS or source IP prefix, and the ASN SAV rule and the IP prefix SAV rule respectively indicates the specific source ASs or the specific source IP prefixes. Besides the terminology about SAV rules, we also add some terminologies about the system components and the main data structure. And about the overall architecture, referring to RFC 5210 and our design, we named the inter-domain SAV system RBIF, short for AS relationship-based inter-domain filtering. And after adjustment, the system has two key components, which is the validation router and the AS IP prefix mapping server. About the validation router, which is short as VR, we mainly updated our descriptions of the validation router to make the function of VR more clear and more specific. And in our RBIF system, existing border routers, they act as VRs, and the VRs, they should exchange ASN SAV rules with neighbors to generate the convergent ASN SAV rules, and regularly query AMS for the IP prefix, and to generate IP prefix SAV rules to filter the incoming packets with the IP prefix SAV rules. And based on the current security mechanism, we use BGP roles to agree on AS relationships when establishing a BGP session, so that VRs can directly get their AS relationships when needed. And considering the deployment and the deployment of different mechanisms, obtaining the AS relationships with RPKI ASPA objects is also an alternative. About the AS IP prefix mapping server AMS, we also adjusted the description of the AMS. It should record the mapping from ASN to IP prefix owned by ASs, and it should offer the corresponding IP prefixes to VRs. And we chose to use our rogue objects from RPKI to offer the information needed by AMS. And as the IP prefix that an AS is authorized to originate may be recorded in multiple row objects, we use AMS function to integrate obtain row objects. And besides the implementation based on RPKI, we think in some cases, like in stable and simple networks without RPKI, a lightweight AMS server can be deployed first. And we conduct simulation experiments using GS3 and use the GS3 Ubuntu image in GS3 Docker as the basic devices. And this implementation has two key questions. That the first is how to obtain neighboring AS relationships. In our design, we chose BGP roles to agree on the relationships, and querying ASPA objects as a feasible alternative. And in our simulation, we install BIRD with BGP roles and let the validation router receive RPKI objects from the relying party. And the second key question is that how to obtain IP prefixes corresponding to some ASs. And in our system design, we use relying party of RPKI to get our RPKI objects, and the AMS to integrate them and provide them to validation routers. In our simulation, we install the routinator as as the line party. And the next step, we hope to obtain more complex illustration shapes and connection scenarios to optimize our RB system and supplement it for special cases and refine it. And that's all. Thank you.
Hello, Nangong from Huawei. Can you go back to page 6? Okay, thanks. Here you mentioned that exchange ASN sub rows with neighbors. So here the neighbor means the AIS, right? AIS neighbors or inter-domain neighbors.
We think the means validation routers of the neighbor AS.
Neighbor AS. Okay. So why the not neighbor AS? I mean, let me rephrase. Accept the announcement. I mean the sub-rules propagated from the local AIS. So why not the neighboring AIS generate the sub-rules locally? Because the neighboring AIS can also obtain the RPK data, and it can also have its own AI mapping servers.
I think I got your idea that our scheme that hope to generate the final sub-rules through the exchanging, not calculate that step by step.
So the calculation happens in the server.
I think that I get your idea, but I let me think that.
Okay, thank you. We can take the question offline.
Oh, okay,
Yeah,
okay,
thank you. Hello, everyone. I'm Nangong. I will introduce inter-domain SPA on behalf of the co-authors. Okay, the inter-domain problem statement draft shows that EFP or RPF may have improper blocking problems in the following scenarios. First is hidden source prefixes scenarios, and the second is hidden passes of source prefixes. So in this document, we propose inter-domain SPA. Here, we define a new message called SPA message. It is propagated through among AISs. In the message, there are some items included, such as source prefixes, source AS number, AS path, and update withdraw flag. Here, source prefixes means those the source AS will generate data packets using the source addresses belonging to the source prefixes. With the SPA, we can it can be used for this advertising hidden source prefixes and discovering hidden passes of source prefixes. Here is an example of hidden source prefixes, that is the DSR scenario. In this scenario, let's look at the figure. There are 4 ASs. Each AS advertises their own rules of P1, P2, and P3. And particularly AS1 doesn't advertise P3, which is anycast server address. If we enable EFPRPF at interface 1 of S2, or if it is enabled at interface 2 of S4, the permission, the allow list will be P1. I mean, only P1 is included in the allow list. So there will be improper block problems if the user if the edge server in S1 sends the data packets with source address P3 to the user located in S2. So in this draft, we propose to enhance EFP-RPF by SPA. It can be used to advertising hidden source prefixes among ASs. Particularly, besides normal BGP updates, S1 can advertise the hidden source prefixes P3 in SPA messages. So if we have EFP-RPF enabled in AS2 or AS4, it can take a union of the source prefixes announced in SPA and BGP update messages. So as a result, the source prefix allow list will include both P1 and P3. Then there will be no improper block problems because P3 has been included in the permission list. The second kind of scenario is hidden paths of source prefixes. Here is an example scenario that is the no export scenarios. In this example, AS1, AS2, and AS4 advertises their own rules of P1, P2, and P4. Particularly, AS1 advertises P1 to AS2 with the no export community. So if we enable EFP-RPF at interface 1 of AS4, the source prefix allow list will include only P2. So as a result, there will be improper block problems when the user in AS1 sends data packets with the source address of P1 to the server located in S4. The packets will be improperly blocked at maybe at interface 1 of S4. So with SPA, it can be used to discover the hidden paths. AS1 will advertise P1 to S2 with no export community attached to the SPA message. And AS2 will propagate the message to S4. So S4 will notice that the S1 exists in its customer call at interface 1. If we have EFP-RPF enhanced by SPA enabled in S4, the allow list will be P1 and P2. So both the source prefixes will be included in the allow list, and then improper block problems will be avoided. And here we have some convergence considerations. And next, here are some security considerations. There are 2 main threats associated with SPA, that is prefix hijacking and path hijacking. In the 2 cases, S4 will improperly include the hijacked source prefixes in the allow list, which results in improper permitting but no improper blocking. Okay, comments are welcome. Thank you.
So because the time limited, so we want to leave some time for the discuss the scaling problem. So
okay.
Yeah, okay. Li Bin, this is.
Hello, everyone. Li Bin Liu from Zhongguancun Lab. I will present the updates of the draft benchmarking methodology for source address validation. The latest version for this document is version 05. This document aims to defining the methodologies for benchmarking the performance of sound mechanisms. To do this, it takes the approach of considering a sound device to be a black box. Defines the methodology in a manner that is agnostic to the mechanisms and measures the performance of existing and new sound implementations. In total, we have updated 6 versions for this document. There are 2 objectives. The first one is assessing which sound mechanism perform best over a set of well-defined scenarios. Another one is measuring the contribution of subsystems to the overall sound system's performance. It can help, the benchmarking methodology can help evaluate individual devices such as hardware or software routers and helps determine the appropriate sound deployment for real-world scenarios. This is the main update summary of this document. We have some updates on sound performance indicators and the benchmarking tests for intra-domain and the inter-domain sound. In detail, we have used false positive and false negative rates to replace the proportions of improper blocks and improper permits. And the CPU and memory is new added. In total, this document has 7 sound performance indicators. We also updated the benchmarking testings for intra-domain and inter-domain sound. And we use false positive and false negative rates to replace the sound accuracy directly. And we added the resource utilization tests. We received 3 comments from the mailing list. First, we are suggested to use the false positive and false negative rates to replace the original matrix because they are more well-known metrics. We agreed with this and we did the revisions. Also, we have more reasons. Blocks and permits are bound with the fixed data plane actions such as discard, permit, and more data plane actions can be applied, in fact, such as rate limit and traffic redirect as defined in the general source address capabilities draft. Also, second, we are suggested to add a new sound performance indicator to evaluate the resource utilization. This is because that high efficient resource utilization is important for the router implementation. We agreed on this, and we also thought that router computation resources are rare and costful. High resource utilization can help reduce the effect on other route processes. We also summarized the correspondence relations between sound performance indicators and the sound performance benchmarking tests. In sum, the false positive and false negative rates are the sound performance indicators to evaluate sound accuracy. And protocol convergence time and message processing throughput are the ones to evaluate the control plane performance. And the data plane sound table refreshing rate and the data plane forwarding rate are the ones to evaluate the data plane performance. And the CPU and memory utilization is used to evaluate both control plane and data plane resource utilization. We also received some feedbacks from China Mobile and new H3C in the mailing list. China Mobile had tested the SAO devices in their intra-domain networks based on the benchmarking tests proposed in this document. And the new H3C acknowledged that the benchmarking methodology is useful to testing their SAO implementations on their routers. We also have a hackathon project called SAObench, which implemented the benchmarking methodology proposed in this document on top of the SAO-OP, which is a SAO open source software. For operators, it can replicate production-grade network environments for SAO mechanism evaluation, enabling operators to identify deployment-optimized solutions through scenario-based performance benchmarking. And for vendors, it can facilitate large-scale topology construction with hybrid software and hardware components, allowing comprehensive validation of SAO implementations. We seek more feedback and comments from our working group in these following aspects. Are the SAO performance indicators proposed in this document sufficient? Do the inter-domain SAO benchmarking tests cover the key real-world scenarios in your network? We also appreciate if you have more comments, and welcome to sending them to the mailing list. Okay, thank you very much.
Okay, thank you. We will leave the last 10 minutes to the Jeffrey for discussion of scaling problems. Okay. Yeah, so you can introduce first. I find the
certainly. So I'm Jeff Haas, HPE. This presentation is motivated by the chairs who have repeatedly said, hey, Jeff, you're making these comments, please take them to the mailing list. So this was a chance for me to write down some of my considerations for scaling and issues for convergence. So why were we having this conversation? Well, the proposals that we've been working through have had some interesting interactions with things like forwarding. When does enforcement actually happen? We tend to be working from perfect topologies and examples. Now, those are actually very good to actually let us talk about the problems for when the state is set up properly and improperly. Methodology is good. This is a piece of good work that the working group is doing. What we're not spending enough time doing, and I'm seeing more of this, and I'm seeing several responses in some of the slides we've had in this session, talking about convergence and incremental deployment considerations, and what part scale actually plays with these sorts of things. So I'm very glad to see that my paper has had some of the motivation I was looking for. Just hitting the points very quickly. Destination-based forwarding networks, this is what we've been using for years. Things are hop by hop, especially for BGP, or IGPs obviously are determining the table from distributed maps. Distributing that state has delays, whether it's a BGP route being propagated or an IGP LSA propagating around the network and a triggered LSA SPF time. Convergence is already a known slow thing. These things happen over time, and vendors actually spend a lot of their energy making their implementations, trying to have the control plane and forwarding planes match appropriately. So key consideration here, time is involved just for forwarding. In a very similar fashion, anytime we're looking at any mechanism that's used for SAV enforcement, when we decide whatever is legitimate for whatever that happens to be your consideration, and we've had a lot of discussion what legitimate means, those enforcement states are an abstraction as a SAV table that takes time to program in whatever mechanisms being proposed. And we have the capabilities draft talking about several different mechanisms that we could use. The time it takes to program that stuff will be somewhere on the order of the same time as programming a FIB, a firewall, and the size of this may be anywhere from a tiny fraction of what we have to significantly larger than the FIB itself. So again, these are scaling considerations in both time and space. what we have as a problem is that if these things get out of sync from each other, and we had the lovely presentation talking about the FR scenario that we're seeing a little bit of chat about in the chat room, being able to turn the stuff on perfectly at the same time without dropping traffic is really hard if you're doing things incrementally. You have to deal with the fact that when things aren't aligned, we've broken the promises of forwarding, we've broken the promises of source address validation. And this misalignment is a thing that we need to be continuously examining when we actually work through our proposals. Synchronization effects are also something that we have to deal with. And of course, the mechanism that we actually leverage is going to impact our scales. Is it the firewall? Is it the fib? Is it a combination? And the combination of these states in the system, depending on their balance, may impact how a given device, much less the system, actually installs things. I picked a couple of very easy examples in my draft to try to illustrate some of these things. They are intentionally exaggerated, but exaggerating things allows you to do the setup for a very basic proof of what happens when you have mismatches in scale. And you can use that as a basis case for a recursive proof as to what happens when you do this stuff across a large mobile system, maybe the internet service provider, or even an IGP domain. We know that picking the easy case, symmetric filtering using URPF works pretty darn good as long as we don't have hidden prefixes. And this means that we can leverage the fib, and not have to spend extra resources to deploy a SAV table on top of it. There's no need for duplication. If we take that balanced system and apply just a simple iterative case, if we start with a fully populated table and we go ahead and add a single entry to it, well, these things are largely still in sync. And this means that the considerations for adding the single new thing is not necessarily bad, but if the fib is getting a new entry and that entry is also simultaneously being used for SAV enforcement, we can have a difference between downstream SAV enforcement of this stuff based on whose fibs are up to date and who's actually simultaneously permitted this as a SAV enforcement entry. Very similarly, if we actually have something that uses different resources, what happens, for example, say if your fib is being supplemented by a firewall table for failover, well, you start getting into questions about synchronization. It's like if you are doing forwarding, one of the conversations that happens is, do you have fib acknowledgements? Fib acknowledgements can be used to provide signaling of this stuff. We are now introducing the need for SAV state acknowledgements to be coupled with the stuff and also coupled into routing itself to make sure that we don't end up in these situations. So when we're actually working through things like static provisioning, the latencies that we see in these things are going to be a big problem. So RPKI, Shriram will absolutely have better numbers than I will, but the systems are only refreshing themselves on a periodic basis. So if you're trying to patch the holes of things for this means that there's going to be strong latency for SAV state to be able to be done. This is part of our controller conversations for actually how do we build these things, much less how do we actually program them. And the symmetry between these things becomes a very important detail. We do understand these things, we have mentioned them, but we're not really talking enough about what they actually mean when you're trying to deploy them. Part of how I'm trying to illustrate this is a very basic topology. It's like, for the most part, if you have a very simple stub AS network, single prefix, advertising off to two providers, receiving the internet feed in the opposite direction, this is a very simple case of what happens for the asymmetry. If you're multi-homed and you advertise the prefix from your customer to your providers, they only have to install a single route into their fib to additionally service you. But simultaneously, that means that if you, for some strange reason, want to actually do SAV enforcement from each of your internet service providers, one prefix advertised will track potentially 1 million prefixes worth of traffic. Obviously, that doesn't happen. It's going to probably come from people that want to talk to you. Who are they? What's most important? That's not possible to predict from the protocol. It can only be predicted by prior knowledge. And this means that you have an asymmetry in terms of what you know versus what you actually advertise. Now, if you flip it the opposite side, again, if we're looking at the provider, it only needs to install a single prefix. We now have a fib-ac type situation. The minute the provider continues to advertise it to further their upstreams, it's going to start attracting traffic. Normal fibs, they still have to deal with getting that synced up and installed for forwarding. But if the SAV enforcement state happens to be decoupled for some reason from, say, the fib, you're not actually using URPF, this means that this also has to be in sync so that the traffic can be attracted. Both of these cases illustrate systems that are moving for the different components, enforcement, forwarding, and routing, and having them out of sync with each other can do bad things. Again, what we're setting up here is this is basically simple inputs for a basis proof where you can recursively say for more and more complicated systems, as we get to bigger networks, how are we going to start having these problems? And again, the motivation for this paper was talk about these things so that people start thinking about them for their various proposals. I'm seeing this inside of the presentations we've had, and that was the goal for my document. I have time for questions and happy to talk after the session.
Thanks. Yeah, I think your considerations should be reflected in the intra-domain or inter-domain document later. Okay.
Okay, no questions. Thank you.
Yeah. Thanks. Sorry to delay the cancel the other presentations. So if you have any questions, I think we can utilize the mail list. Okay. Because it is the normal tool for the IETF related works. Okay. Thank you.